All right, here we go. Let's work through these free response questions. Now, these are ordered from chapter 1 through chapter 4 right now. So, our goal is to just kind of take them one at a time, make sure we kind of know what's going on. I'm not going to go the full in-depthness, but I will talk about really what the AP is looking for in this first one. Okay, so on the first one here, we have a stem plot, and we call this a back-to-back stem plot, where we see um, right? Like, whoops, we see machine A over here on the left side, and we see machine B over here on the right side. Now, the way that you read these things is from the inside out. So I would read machine A going this direction, and I would read machine B going this direction, right? Now, they put those stars on there on purpose because we don't know exactly what those numbers are, and they did that on purpose to get us to kind of really think through concepts versus actual numbers to drive this. So the first thing that we want to notice is that we're ranged from 14.1 to 15.9. So obviously on one of these right here, that's 14.1, or maybe that's 14.1, but this one here down here is going to be 15.9 for sure. So the way I'm reading it is the branch in the middle, right? The stem, I guess you would call it, is the 14 or 15, and then the line is the dot, and then every one of those little things, these little stars that are after it, right, is another number in this thing. Okay, so let's get right to it. So in chapter 1, we talked about this idea of compare. Whenever I hear the words compare or describe, I want to think about my socks. Now, when I compare, I'm going to compare the socks. I'm going to compare in that realm, right? So I might just do, like socks. I would say that, well, I'm going to say that both of these are, well, they're kind of symmetric in a sense. The machine B looks like it might have a little skew to the right, and maybe you would say machine A has a little skew to the left because that one that might be an outlier because I see a gap there. So let's just say I'm going to go with machine A is mostly symmetric, where B is slightly skewed right. And now you see how I'm comparing within my socks as I do that. Oh, machine A has a possible outlier where B doesn't. Center. So this is where we can kind of actually count. So watch how I do this for machine A. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So halfway between 36 is the value 18, right? But this is an even number. So between the value 18 and 19 is where our mean is, right? So now I'm just going to come back. I'm going to double check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So let me just show you. 18 is that one. 19 is that dot there. So whatever this value is right here, that is our mean. So what we're going to do, going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. 38. So 38 and a half is 19. It's an even number. So between 19 and 20 is actually where our value would lie. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 19, 20. All right. So how do we, I don't know those actual numbers, but I can see that machine B's median is going to be less than machine A's median because of where they are located in there. So I'm literally going to say that machine A median is greater than machine B. Okay. And then spread, let's just talk range. Range is super easy to do. So 14.1 all the way to 15.9 on B, 14.1 up to 15, less than 15.9. So we're going to say this, machine A has a smaller range than machine B. All right, so that's it. So compare means socks, but using comparative language, right? So really kind of like putting them against each other on that, all right? Part B, the company wishes to be consistent as possible when packaging the snack bags. Which machine would be least likely to produce snack bags to have a consistent weight? So we're looking for the least likely. So that means the one with the bigger spread, right? Bigger spread means more variability. More variability means your bags can end up all over the place, right? So least likely, we're going to say machine B. And then it says explain because it has more variability in its distribution. Right? So that's really it is. If you'd like to use the word spread instead of variability, you're kind of right on. You're right on there. But talking about spread, that's what really gets us going on that one. And then finally it says, suppose the company filled its bags under machine you chose in part B. So they say they're using machine B, right? So it's least likely to have a consistent weight. Which measure of center, mean or median, would be closer to the advertised 15 ounces? Explain why you chose your measure. So I'm going to say this, since I'm going to use machine B, which is not as consistent, we already know that the median here is going to be between these two values here, which is going to be 14 point something, probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? It's probably 14.7-ish, right? Which isn't going to be close to the advertised 15 ounces. So I would use the mean. So here's the other thing to take note of on this is know that if I were to draw on top of this, remember this is skewed right, right? It's not a heavy skew right, but guess what happens when we start getting a skew? The mean will be influenced by skewness. So it will be greater than the median. All right, so that's really it. So it's really thinking about what happens with the mean versus the median. The median in this in machine B won't give me as close, but the mean will have to be greater than, or it's going to get a little bit further. And I don't know how much further it's going to move, but it shouldn't be the same as the median because of the skew right nature of this. So that's kind of what you have there for the first chapter. All right, let's look at the second chapter. Second chapter is this one right here. Okay, so second free response question. So use a sketch of a normal distribution to illustrate the proportion of students who would earn a B. So we're looking for these people right here, and we're going to use a sketch of a normal distribution to illustrate those. So really, we don't need to actually calculate that. Oh, actually, we do calculate it because then it says calculate the proportion. But they're really looking for this first. So here's what we do. We're going to take, it says it is normally distributed with a mean of 82. So they at least give us where this is going to be, 82. And then a standard deviation of 5. So if I needed to, I could continue to represent all these different values here. But I don't need too much of that. What I need to know is where is 85 and where is 94, roughly on a graph. And then we'd shade all of that part right there because that is what we're talking about. These are the people who earned a B, right? The percent of people who earned that or got it correct, got the grade of B if you were in that percentage there, right? And then we want to just calculate the proportion, right? So what proportion of people are actually in there? So I'm going to do that. I'm just going to calculate that. Now, sometimes I might have to actually do a z-score to kind of remind me of this. I'm not doing a z-score right now. Let me show you what I'm going to do. I'm going to do normal CDF in my calculator. 85 lower bound, 94 upper bound, 82 is the mean, 5 is the standard deviation. So literally going to get my calculator and do that value right there. So just a moment. 82 and 5. So it looks like I'm going to get an answer of 0.2661. And that would do it right there. Calculate the proportion. That's what they're asking us. So this asks two things. This is an AP style question. They ask for a sketch, good. They ask for a proportion, good. So those are the two things we want to be able to show. And if you miss one of those parts, you can't get full credit for that. So just be in the habit of doing that. All right, part B. Student who earned a B, C, or D are considered to meet standards. Based on this grading scale, what percent of students will receive a score that places them in a category other than meets the standard? So we don't want to meet the standard, right? So here's really what they're asking us in. Let's look at our little curve, 82. And so they say, right, because other than meets standards. We don't. So that means they are getting an A or getting a F, right? An A or an F. So let's see, it's going to be people that are 94 or better, and we're also going to include the people who are getting a 65 or less. Okay, so we're going to be doing both of those. So again, drawing the curve, shading the curve is a great foundational way to show that. Sometimes we're going to throw a z-score in there, but for the moment, let me just, I'm just going to actually I'm going to find a little proportion here. I'm going to find a little proportion here. And then I'm going to add those two proportions together, and we're going to be golden. So these are going to be normal CDF functions again, right? So the first one, my lower bound is 94. My upper bound is infinity, 85. So if I got that, it'd be 0.00819.8. All right, and then I'm going to do the other one. So I'm going to go normal CDF. But now my lower bound is negative infinity, so I'm going to do negative really small number. My upper bound is 65, 82, and 5. So I get a real tiny value, it says 3.3698 e to the negative fourth. That means I need to put 1, 2, 3 zeros in front of the 3.3698. Now I'm just going to add those two together, and that's going to be my actual proportion. So I'm going to go plus 0.008197.5. That should be good enough. And I'm going to get 0.0085. Sounds good enough. And that would do it, right? Other than meet standards, right? Because all these in the middle that I just highlighted in yellow is meeting the standard. So there we go. And then finally, see what grade would the student have who scored in the 25th percentile earn on this chapter. So let's talk real quick about reversing this, right? So we still know this is a basic curve 82. So there's somewhere that in here that there's a value that if I were to shade less than that value right here, I would be shading 25%. Because remember, percentile itself means shading below, or how much data came before it. So essentially, we could create a z-score, right? So we could go z equals x minus 82 divided by 5. And then we could go look up the z-score that is as close to 25% as we can on the table and replace this z value with that number. Or, let me tell you what I'm going to do in my calculator. There's a thing called inverse norm. So inverse norm allows me to put area. So my area is 0.25. The mean is 82. And the standard deviation is 5. So literally going to do this, and I'm going to get my value for x. It's going to tell me that value, right? So my calculator does the work for me. Now, I need to show a curve, or I need to show a z-score. I got to show something as proof. That's called the justify your answer. Your calculator is not a justification. So 0.25. Mean is 82 and 5, and my tail is left because I want it to shade left of that value. So I'm going to do that, and I'm going to get 78.6 Let's just call it that, 78.6. So again, justify a curve with the shading to show that is justification, or show all your values in here. That's justification. You got to show something. This, what I just wrote here, is not a justification statement. It's good. If you want to add it, it can't hurt you, but it's not justification in AP realm. So make sure you're drawing a curve or showing a z-score, and that's why I want us to be in that habit. All right, that's the second one. Let's go to the third one here. So the third one here, this is in chapter 3. This is bivariant data. So this is really, this one at least, they don't actually show me a scatter plot. Sometimes they'll show me a scatter plot and I'm thinking FOD, form, outlier, direction, strength. This one happens to really highlight on the computer output. So we want to be able to do that. So first one says, write the equation of the least squares regression line, define any variables used, interpret the slope in the equation in context. So it's actually two questions in the one question. Write the equation of the least squares regression line with the definition of variables. So we're going to do that together. So let's kind of do it generically. Here's one of the things, remember we talked about back in the day, when we see the word constant, then we go check its coefficient, and that is your y-intercept. Go find the descriptive word, in this case it just says x, and that number that's under its coefficient tab is called its slope. A couple other things we also looked at here was the S value, which is the standard deviation of the least squares regression line, also known as standard deviation of the residuals, and the R squared value. So those are things that we looked at. We literally said, at least for now, until we get further into what we're doing in stats, we are going to ignore all the other junk. So don't get caught up in all the other junk right now, okay? So write the equation of least squares regression line. So let me do it very generically first. Y hat, and yes, I put a hat above it. Remember, you got to have the hat, is equal to 10.28, right? So pulling that number up there, plus, it looks like that's going to be 4.92 x. So this is great. This is great. This is the least squares regression line, but then they asked us to define the variables that we're going to use, okay? So now we're going to go back and we're going to find the amount of fire damage is y, and the distance between fire station and residence is x, okay? So the amount of fire damage. So watch this. We're just going to do amount of fire damage. And remember, I put that little hat above it again, right? Saying that the predicted amount of fire damage is equal to 10.28 plus 4.92 times, what's the next one? It's the distance. I'm literally just going to say distance. And then we could further define distance as distance between home and fire station. Okay? So there is the first part of the question there. Second part of the question is interpret the slope of the equation in context. This is the slope, that number right there that's attached there. So in context, we'd say for every added, and what did they do distance in? Whoops, let's try that again. In miles. For every added mile away from the station, we'd predict, and that's an important word, predict the fire damage to increase by 4.92, and that is in thousands of dollars. Thousands of dollars. Right, there's the slope right there, right? Taking the actual slope value there and just saying what it means. Remember, here's in general. For every one of these, this changes by that slope number. And now we're talking predicted, right? Because that is a predicted value. So we would predict that fire damage would increase by 4.92 thousands of dollars, or $4,920 would be the predicted increase for every mile further you live away from the fire station. Okay, part B, a home located 3 miles from the fire station received $22,300 in damage. Use your equation to calculate and interpret residual for this observation. So here's what we need to do first. So this is we'd call this the actual damage, right? The actual amount of damage. So now we need the predicted amount of damage. So let's do this. Let's go y hat equals 10.28 plus 4.92 times living 3 miles, right? So we're just literally going to plug in 3. So we're going to get a y hat equals, let me do this in my calculator real quick, 10.28 plus 4.92 times 3. Looks like we're going to get 25.04. Remember, that's thousands of dollars, right? So if we recall, residual for any x value, in this case, when x is equal to 3, is actual y minus predicted y. So in this case, the actual y is 22,300 minus the predicted y is 25,040, right? So that would be the actual number. So I'm going to go 22,300 minus 25,040. And it looks like I'm going to get a negative residual, negative 2,740. So that's how far off we were on our prediction for that one value right there, right? So, but that's it. That's all I wanted to know. Now we could go ahead and build an entire residual plot. It's not asking us to do that right now, so we're going to skip that for now. Okay, and then identify and interpret the correlation coefficient. Correlation coefficient is also known as the R value. Right? That's what we're looking for here, the R value. Now, they don't give us that in here, but what they do give us, they give us the R squared value. So, aha, R squared is equal to 0.9235. So how do we go from an R squared to an R value? Simply square root. So R is equal to, I'm going to take the square root of 0.9235, and I'm going to get 0.96098, right? Or really, I'll probably report this value, 0.96. Now, the last thing I need to do is double check, because your R value should match your slope direction, right? So if my slope is negative, I would need to change my R to negative. If my slope is positive, I keep my R positive. So come look at the slope. Remember, slope is positive 4.92. So I'm going to keep my R value as a positive there. So let me just rewrite this so it looks better. R equals 0.96. That's it right there. Correlation coefficient, R value. All right, so there's number 3. And let's jump right into number 4. Number 4, we are talking about sampling versus experimenting in chapter 4. And so what this was about, describe how you select a simple random sample of 200 students in the district, right? So, so we have this, I basically say get a list of every student in the district. Give them each a unique number 1 to n, right? However many we got total, which I guess I could have just added that up. What, 2,000 in elementary, 1,000 in middle, and 2,000 in that. So what is that, 5,000? So let me just 1 to 5,000, right? Use a random number generator to select 200 unique numbers. Now, I'm saying unique numbers or say 200 numbers without repeat, right? That'd be another way of saying it. But that's a simple random sample. Another way you could say it is put all 5,000 names into a bowl and draw out 200 of them. That's totally fine. That works as well. You can come up many, 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 many different ways to kind of say the same thing. You just come up with one that sounds great to you. Part B, describe how you select a stratified random sample consisting of 200 students. So a stratified random sample is where you break into groups and then you go visit every single group and it guarantees representation, right? So stratified random sample, then we would stratify by schools, school type, right? And then take a simple random sample from each type. So example, elementary, middle, and high school. And we'd probably try to keep it proportional, right? 2, 1, 2. So, right, if we did that, so then we would say like 2/5 of 200, right? So we'd take maybe a simple random sample of 80 from here, a simple random sample of 80 from here, and so then we take a simple random sample of 40 from here. That way it just keeps it proportional, right? Based on the number of kids who are in each of those different realms, right? Would be nice to just kind of have it to stay proportional. But that's it. There's nothing that says it has to be, right? I mean, if we want to go take a simple random sample of the same size from each group, that's totally fine as well. But, just doing my best to keep it very proportional. Part C, describe the statistical advantage using a stratified random sample over a simple random sample in this study. Remember, we said stratified random sample guarantees representation from each school type. All right. There you go. There's those 4 right there. See how you did? If you don't have the exact wording or the exact phrases, you're going to be okay, right? AP is graded by human beings with eyes and with brains that is trying to assess how well do you know the statistical content. Now, the more we can use the actual statistical words and the justification behind it, the better chances you're going to get 4s on each question, right? So keep that in mind as you're writing these things out, all right? We will keep working.